Okay, today we're going to discuss how to connect a Festo CMMO-ST-LKP controller to a Festo CTEU-EP, which is an Ethernet IP module, and then they have a CAPC module, which converts the Ethernet IP to iPort, and this CTEU is going to be connected to a ControlLogix or CompactLogix. It's all the same thing, to the Ethernet master. And this is the general layout. We've got one controller connected to one of the two ports on the CAPC, and that's what we're going to talk about. My name's Stephen Proud, and this video will have text below it on YouTube, and whether it be now or later, there will be some links to some Dropbox code and some samples and so on and so forth. So there should be a zip file with a variety of information that can help you accelerate what you're doing. So again, this document's not necessarily finished. I'm just in the middle of doing this. Just want to get this video out there real quick. Okay, so the CTEU, like I said, it has the Ethernet IP. We're using the Ethernet IP this time, not the Modbus portion. It has two ports. It has a switch inside of it. Standard ring technology stuff like usual these days. You can buy a an adapter from Turk or from Festo. There's the part numbers here if you want to avoid using the IP65 connector on it, which is this connector right here, 65, 67. So this connector is the normal way. You'd wire it yourself, and then if you don't want to do that, I mean, you can buy cables from a variety of manufacturers that go from an M12 to an RJ45. There is a power port on the top here that, like on most products, you've got a load or electronics power. So there's electronics power and then there's load power. And this is the wiring for it. This is included in the guide. There's some LEDs here. The status is included in the document that you'll have in the zip file. And then some dip switches. So basically, everything is off. The IP address is here. I used Festo's Festo field device tool to set the IP address. And that's it for the module here, for the CTEU-EP, and this sits on top of the CAPC as shown in the previous video. Then you've got the CMMO-ST-LKP product from Festo. I include some wiring. Here's your iPort wiring right here. It's not very difficult. It's just 3 wires, just like wiring a sensor. You've got 24 volts for I/O. This is there's a top and bottom view if you look here. So there's just two different, same wiring, but different top and bottom viewpoints. Same thing with the X9 wiring, which is the logic and load power, just different viewpoints. And then this motor wiring, typically the motors come pre-wired. And we're using a ControlLogix processor. Like I said, a CompactLogix, all the same. And that's it. So next step. So I've already configured this. So I'm just going to go offline real quick. So to get online to any FCT type device, you go up to component and you can scan the network. So I have a couple CMMOs on here. We're just using one. I've already selected, so you would hit OK at this point to select the device. So you hit 96, OK, hit OK, and now up top here. Let's quickly go through here. So this is just some basic axis, your axis might look a little different. The whole purpose of this FCT software is to configure the hardware and then give it a couple of parameters. iPort is the interface. We're not using IO-Link or Modbus. I've added these things here. This is relevant to whatever application you're working on. I've got zero load. I've modified the tuning a little bit just to suit. This default axis operations. I don't have a limit switch or anything like that. I'm just homing where I am. So I've just current position. Drive to 0. Got 100 millimeter stroke. The firmware, as you've noticed here, is 1504. Firmware is very simple. You go and you download the firmware from the internet on the support downloads page. So www.festo.com, and then you click on the top, the support here, and then you come down here, type in whatever your product is, select it, and then you find all the relevant information for the different devices. So there's the firmware 15014 that's out. I'm a little bit older, but this is what I'm using for this particular show here. And you download it, and you would simply come through here. You select your folder, and then you say download, and then it's done. Closed loop settings, Fieldbus. Okay, this is very important right here. Factor group is of no value. It's set in stone. So there's two options here: FHPP standard and FHPP plus FPC. So Festo handling positioning profile. That's where you have the control area. You set the motion, get the feedback of the axis position, things like that. The FPC is called the Festo parameter channel. It is where there's an extra set of AOIs or function blocks included in the Festo library, and you can parameterize FCT. For example, if I want to change this value here, I can use that parameter channel to update this value or read the value. Default values. So the next important thing, which we'll come back to at one point, direct mode. So the way the FHPP data is comprised is it sometimes uses a percentage of the values that are in here, or are hard setting them. Jog mode, normal stuff. I've got a couple of records in here. There's a couple tabs at the top here. I just have some basic moves here. Messages, defaults, errors, defaults, so on and so forth. So that's it for that. At the bottom here, once you get online, this is the commissioning area. So I'm just going to go online right now. So when it comes to commissioning, you've got these little boxes down here. You of course need the I/O on active in order to do anything, even though you're using a Fieldbus, which is iPort in this case. And if you have that enable, then you can enable the axis and do a couple things. So I'm not going to home it because I've done that already. Manual move, I can just move this forward, hit the software limit. Software limit's 97, so hit the limit. Acknowledge the error. Jog in the reverse direction. Simple little things. Optimizing tab. I'm not going to get into that. This right here is important because this is showing you the data that's being passed back and forth to the PLC. You got message to, message from, and monitoring. You've got some temperature here, and then diagnostics. You come in here and you do a read, and you can look at all your errors. So additional to the commissioning down here, in your record table, if I've actually homed the axis, then other features are enabled, like this button right here. And in the page right here, if I want, I can come here, select the page. I'm going to tell it to go to position 20, hit the button. It moves to 20 millimeters, stops, so on and so forth. Do another one, move to 10. Okay. So it's that simple. So we've done our commissioning now in the FCT software. We know that it works. Now we move on to the the PLC code. PLC code. So I'm just going to go offline real quick. So again, I have this project which is again embedded in the thing. So the EDS files, I hope you know how to install an EDS file. If you don't, you go through here, you pick the file that you've downloaded from the internet. Again, come into here, into this Festo website here, type in the bus node, come down to software, go down to the EDS file, and there's your EDS file. Download that and use this EDS installation tool. Whatever, stupid Windows. Yeah. Come on. There we go. Hit next and then next and then register a whole directory, go browse to the folder, and then you say next and it does it all. All right, so I've already done that. And of course, the first thing we want to do from ground up is to add the device. So here's my device right here. You would come through here, whatever your Ethernet master is, you basically come in here and add the device. Then you come in, say new module, come in here, do a search for the installed EDS file. You would say create. At that point, you come into this right here, give it a name, give it an IP address. Let's see here, what's next? So the most important part is understanding this I/O size. So got a couple different options here. Because this particular CTEU-EP module or EIP, they call it back and forth here, it means different things based on how it's installed in what situations. So when it's installed on the CAPC device, the idea or the concept here is to match what you've done in the FCT software. So in the FCT software, as we discussed earlier, we have this Fieldbus tab. And there's two options, FHPP standard and FPC, or FHPP standard as a standalone. The FHPP standard takes up 8 bytes, and the FPC area takes up 8 bytes. So if you choose the standard, you have only 8 bytes in and out. And if you choose the standard FHPP and the FPC, then you have 16 bytes in and out. When you're in the configuration here, this is configured for dual port 32 because it amounts to 32 inputs and outputs for the entire CTEU. And you need to have 16 bytes of information in and out on each port. So that's why there's 32 here. If you were only using, and you can't isolate it down to one port. So you have to say that it's a dual port because you're sitting on a module that has 2 ports, and the 32 represents 16 bytes per port, which allows the FPC area. If you were doing dual port 16, then that means that you would only be using this right here, because one port is hooked up for that, but I'm not going to do that. So I'm going to hit cancel, make sure that's still there. Yep. All right. So then there's the typical stuff, you know, unicast selection. You don't want multicast in your network ever, as far as I'm concerned. There's some configuration data, which I haven't touched at all. Everything's default. I'm sure there's some neat or some cool looking things in here, some parameters, things like that. We're not doing any device level rings. Okay. So you have that configured, and because it's called CTEU-EP, then you now have CTEU-EP control input and output, and you have some data. I've taken the liberty, it doesn't do this automatically, of labeling where the device structure sits. So this here, device 1, that would be port X1, for example. That's the first 8 bytes. Device 1 FPC is the next 8 bytes. And then device 2, which is the X2 port, would be the starting area here, and then so on and so forth. I think you get the idea. Same thing goes for the inputs. I think I labeled it. Yeah, so same idea. Control area, you might have some interesting bits that you want to use in here. I'm not getting into that detail. I just want to make it right. Just want to make it work. And now we have to use the add-on instructions. So when you download from the website, let's go, we're talking to a CMMO, so let's go back to this here. Part of the zip file that should be on the Dropbox location will have this library right here. So you're going to download this library, but I've already got it embedded in the files in the library directory. You download that, you unzip it, and then you install all the add-on instructions. You know, let's say import so like I said, you'll get this area right here. FML read, write, so on and so forth. So you basically import them all. And one of the things that you'll find within the library is you've got duplicates of certain variable AOI, sorry. And some have the underscore version 20 and some don't. So through experience, I've realized that the version 20 is for version 20 RS5000 software or LogixDesigner only, and all the rest of them are for version 21 or newer. So basically this library is for version 20 and up. So basically you select this, you would import the library, import this, and it also imports tags as it's bringing them in. And you basically continue until you have them all in there. Within the structure of the exe file, when you've unzipped it, you'll find that there's a documentation directory that explains the library itself. The purpose of this video is to kind of accelerate that. Okay, so I've taken the liberty of taking most of the tags out. So the important concept behind the library is that as a minimum, you need 3 AOIs. You need a FML read, which sucks data from the CTEU module and brings it into this data ref tag. And then if you go to the very bottom of this rung here, you need a FML write, which takes the data from the data ref, takes the data from this data ref tags and shoves it into the output data going to the CTEU. And then if you go back to the top, scroll down, you need this FHPP control. So this FHPP control is what you use to control the access. So there is a data map, shows you all the individual bits and bytes, but you really don't need to care about that, except for when you're looking for understanding on how something works or what bit is, so you look in the manual and away you go. So basically, recap, FML read you need. This is reading inputs from the CTEU-EP, which is connected to the CMMO. And at the very bottom, you need a FML write, so on and so forth. So with that, you need to configure it. So I've got a couple blurbs in the description text here. The device type is 10. If you read the library literature, it says 10 is the CMMO-ST. Modbus we're not using. Basically for a IO link or iPort setup, it's all the same. High byte first is 1, Modbus is 0. And then you need to specify the data. So as we observed earlier, you have these tags right here. So you've got the input data, and you want to specify the starting address. So you specify this data, and then the array number. So there's your data. and the starting address is 0 for that. And then the CFG FPC, that's saying, are you configured as using FPC in the FCT software? Again, this relates back to right here, this FPC, we are using it. In order to utilize all the AOIs, we need to have that turned on and set up like it is here. So we turn this on, and then because we are using it, we specify which array starting addresses. So if you go back to here, we're starting at array number 8. So this is where the FPC starts, and that's what we're saying right here. And that's all there is to setting up this tag. There's some status and so forth. If I go to the end of the document here, it's the same concept. We've got FHPP area, which starts at array 0. Again, there's the O data, which relates back to, the O area, the outputs area. So this tag right here, and you're going to specify this is the 0 array. That's the 0A. This one's starting at 8. Config FHPP out. Oh, I never even noticed that. Interesting. So config FHPP out. Oh, that's FHPP plus. So we're not using plus. Plus is a different thing altogether for different axes. This particular controller has no FHPP plus, so don't concern yourself with it. So again, up here, we're not using FHPP plus in either, and we don't need to specify anything. So the read and write is set up just the way it is here, and once you have that set up, the data ref is being passed to here, and away you go. So I am going to download or go online. So go online. So we've done a download, we've configured the code. I'm just going to download and overwrite. Put it in the run mode. Okay, so we're online and we're here. So let's see if we can make this thing work. So the sample code I have included. There's 2 PLC programs, and you'll see here that this says move no. This is labeled wrong. This should actually be move yes. But anyway, there's 2 pieces of code. One piece of code has only this library here, because this is all you really need to run everything. You can test it and fiddle with the numbers here. And then this particular code here is a move yes. Okay, so I basically quickly changed this to a move yes. But basically the difference between the other PLC program and this one is that I've got a bunch of routines in here in this program that actually have code to show you a little bit about how to program and operate on the AOIs. So again, this AOI right here, or this routine has this AOI right here. And I've got this main routine right here. So I've got this bit here that I just, toggle back off and on, toggle bit, Control T. So Control T, it turns the code off and on. So when this is off, then the PLC code is not executing, and therefore you can just manually play with these controls right here. 0, 1, and if you go to the FCT area, you'll see here. Okay, so first point is that if the FCT is enabled, just like down here in the corner, the FCT, then the PLC cannot gain the control sovereignty over it. That's a learner's permit 101 here. So I'm just going to turn this off, and you'll see that the enable and everything are off right now. You get the status here, and you'll see now that they're on. Drive enabled. To get the control sovereignty back, you need to basically turn the enable off, turn it back on. So drive enabled and ready, and go from there. So at this point, you can flip the bit, start homing. I'm not going to do that. Again, I homed this already. And then we get into different modes of operation. So when you're in mode 0, as shown up here, record mode is 0. Then what you're going to do is you're going to be executing these records that you've previously downloaded and stored into the controller. So if I execute move record 3, then we're going to move to 50 millimeters. So I come down into here, type a 3 into here, come down into here, put a 1, and it moved to 50. If I come into here, put a move 5 in, 5, turn the enable this all on the rising edge, so 0, and it's moving to 95,000, or 95.000. You'll see that you've got 3 zeros here, and you've got only 2 zeros here. Basically, in the Fieldbus tab, there's a factor group which has got the exponent level here, which shows you, you've got 3 decimal places right here. So everything that's passing is whole numbers, and it's basically you need to scale it yourself, which I'm not going to do for you. So you'll see here that every time the start task goes on, you get acknowledge start. The concept behind doing a move or any move is basically you turn the start task on, wait for the acknowledge start, turn the start task off. Now you know the move is executing. Then you wait for the motion complete, which is right here, motion complete. And that's it. So I'll turn this off, go into, so that was record mode. Now we're going into direct mode. So 1 is direct mode position. So direct position mode. And when you do that, then you use these values right here. And you'll see that there's a velocity and a position. Well, the velocity in here is not a unit of millimeters or anything like that. It is a 0 to 100%. And it's a 0 to 100% of this right here. So direct mode, base velocity is set up right here as 20 millimeters. So if I put in 100 here, or 50 in this case, then I will be requesting the move to be executed at 10 millimeters per second, which is 50% of the 20. And the accel and decel for direct mode is all right here. That's hard set in stone. And you give it a target position, so on and so forth. So we're at 95,000 right now. If I simply turn the start task on, we're going to tell it to go at 10 millimeters a second to position 50. So now it's moving. See how it's moving? There's your actual velocity, minus 50, because we're at, and you've got your actual position. If you go to the FCT now, you'll see here that you're at 50. It's that simple. It's not a bad little controller. There are some other modes, but I'm not going to get into it. So let's see here. So I'll get into this code in a minute. Let's just talk about the rest of the AOI. So among the other AOIs, there's this one called FPC. So there's a lot of FPCs. See how they're FPC, FPC, FPC. So basically the first thing you need to understand is that all of these instructions need to be on a rung that's active all the time. These bits right here on the left, these are just, communication status, whether the master has been faulted or whether the module itself is not communicating. This one right here, make sure that you are configured. That's this bit right here. Because unless you have that, you don't want to be able to try and do that because you won't work it. It won't work at all. So this right here, if you go into the manuals, I just opened up this book up here, this manual from the website, which is also in the link or the zip file. You'll find this. There is this data area, and within this data or this manual here, you'll see that there are FPC data map. It talks about how this works. A little convoluted, but easier just to do in the code. And then there's parameters, and it shows you that there's different parameters and so on and so forth. So this right here, for example, 541, base value speed. So if I want to modify this value or look at this value, it shows you that you have the units. So, and it shows you what the increments, so on and so forth, and so on and so forth. So you come into this here, and we want to do a read. So we turn off the write. We type in 540, type in subindex 1, so that's matching the PNU of 540, the subindex of 1, and we simply execute. And we get it done, no errors, and the actual value is 20,000. Well, that matches this value right here. Now, so let me just prove that that's working. So I'm just going to upload, because we're offline, we're not in control, we're just uploading, so that's okay. I'll turn this back off now. Let's say I want to change it. So 20, actually let's go 30. So 30 millimeters a second. I'm going to do a write. I'm going to execute the write. It's saying, hey, I put it there for you. Turn that off. What the heck's it doing here? It's going to crash on me. Turn that off. If I go into here and do an upload, yes. Hey, changed to 30 millimeters per second. So there's a typical sample of read and write PNUs. Now the funny thing is that I chose a simple thing, the base value of speed, which is a common thing you would want to change. Well, common or not, I don't know. It's up to yourself. But there is a specific function block that is meant to change the values for direct mode, and that's called this FPC direct MP. So this is already set up in here. It uses the same concept, same area. You just don't see it happening. Basically, you come into here, do a read. It reads these velocities, puts in, don't confuse the top with the bottom, because this right here is the actual. And okay, so I did a read, and we've got 30,000, 40, 400,000, because this is this is meters per second, whereas this is millimeters per second. So this is meters per second squared for XL decel. So I'm just going to change this right here to 46. So turn this off. I'm going to make sure that it's going to write now. I'm going to write to it. It tells you, hey, I wrote to it. It's done. Turn the bit off. And go and upload. And you'll see here that it changed that and that. So if you're going to change those values, then it'd probably be best to use this here, because it's just a little more sensible, that's all. Just going to put this back here, lower these speeds down. What is it there? It's 4, I don't want 4.6 meters per second. I want like, that's a little slow. One more 0. So we've got 1 meter, 1 meter, and then we've got 20 millimeters. That's plenty fast enough for this particular show here. So recap, this FPC PNU, you can modify any parameter you want. You notice how this execute is off right now. You can never have 2 FPC AOIs active at any one point in time. That's what I was trying to say earlier. I must have lost track. But basically, anything with the FPC, any FPC AOI cannot be executed while the other one's being executed. So If I come into here and do a, I'll just show you what not to do. So come in here, I do a read, I get it done. That bit's still on, so it's still an active. Come into here, execute this, nothing happens. Okay, so it's basically jumping over the code. It doesn't give you an error, but it doesn't execute it. So don't sit there scratching your head when you're trying to do two things at once, or you're frustrated because, hey, this did it one time, it was a race condition, you got lucky on the one time, and so forth. Basically, only one FPC active at any point in time. Then you've got this next area here. So let's try something. Execute one. And I get no, I don't have any faults right now. So let's make a fault happen. What can I do? What can I do? Oh, let's go up here and do a jog. So the axis is jogging. It should hit the over travel. Yep, there's a software over travel. That's an error because it's configured as an error. And if I come down here to this AOI now and do a read, now it's 17. If you were to go into the manuals, or let's just quickly go to the help file. Special topics, error handling, 17. That is, was it 17? No, it's an 11. That's why I do this here, because that's a decimal number, and then we put it into a hex value. So we go back to here. 11 is right there. Software limit over travel. So you can do some code based on that. Shove this into a string or something to give it some strings. So that's how this particular one works. Turn this back off now. All right, so FPC Multi. FPC Multi is essentially the same thing as the individual FPC PNU, but you set up an array, which you can look at the code wise, and within each array is a structure of one FPC PNU, and it basically contiguously writes the array. So you could set up a bunch of parameters, like let's say the record table. You could set up the record table parameters and then do a read and write. If I do a save here, LogixDesigner, size of parameter, that's the array size. Let's do 6, execute. It goes through and does all 6. You get it done. If I now upload, it just changed all these values right here because of how I set up my array. I'm just going to close this, say no, and then reopen it. I don't want to screw around with it anymore. Go back online, do a download, overwrite the stuff. Also, when you're doing a download, it automatically, if you didn't read that real quick, see how it's got the FCT checked again? Store. So it puts this checkbox on, so you have to make sure you turn it back off and then gain the control sovereignty back again in the software. So that's what this is here. I've got a couple structures here that are writing the same array, so I could do different read writes. And then you've got this last one right here. This is actually quite important. I will do this. So we want to do an upload. So 0 for download, 1 for upload. And what this is going to do, I'm going to say execute. Hopefully I've got nothing else screwed up here, but basically hit a 1. Okay, now it's basically uploading 21,948 bytes of information from the controller. The CMMO-ST controller is designed so that you can read the entire image or the entire parameter. So the FCT software that we've just been showing you, or that I've been showing you here, it's uploading everything that is configured here. You know, all the values are stored in bytes, and it's now shoving it into this this file array here and populating that, so that, you know, perhaps later when the CMMO-ST controller craps out or fails, you can simply come down here, toggle this download bit on, and then download and overwrite everything. And it works pretty successfully. I've actually tested it in the past, and it's just a little slow right now because it's going out Ethernet IP, and then the IP, Ethernet IP is being bottlenecked into a AOI port, and then get into the access. So it'll take a significant time. So I'm just going to stop real quick and pause the video. Okay, we're still executing this instruction here. The I port is extremely slow. You can probably set up IO link the same way. Might be a little bit quicker, maybe the data protocol a little faster speed. But basically, as it sits right now, we're doing about 3,000 bytes for every 2 minutes. So the whole process should take about, I don't know, 15 minutes. So I'm just going to pause the video again, let it finish. It's a little bit sure we're almost there. We're at 20,000, another minute or two. Okay, we're close to the end here. And done, finally. Okay, so now, turn that off. Basically, this data file here, which is a 25,000 array, has all the values of everything. You know, you don't need to understand what they are, and it's not going to tell you what they are, but it's basically, it's taking a snapshot of all the different values of the parameters that are in the FCT software. And that's all there is to the library as far as the AOIs go. Now I'll just talk about my codes. So, so this main routine. So I'm going to turn this on now. Okay, so code's now active. Excuse me. So these bits right here, you can just toggle them off and on and go into different modes. There are 3 direct modes, and there's 1 record. In my sample code here, I'm only showing you direct mode, position, and record mode. As you see here, there's a couple routines. So you toggle this, hit the T over here, and it goes back and forth between the modes, and that basically shoves the value into this operation mode, which is this bit right here, this one, OPM operation mode. So you selected the modes. So we're going to do direct mode for the time being. This rung right here, you've got the enable, stop, and halt. The stop and halt, leave them on all the time. Don't ever use them for anything other than putting them on all the time. The enable is what you use if you want to do something like dropping something, do an e-stop. These 2 bits right here are a status from your control relays, you know, your e-stop or your gate relay, and so on and so forth. This is just my own internal bit, just create drive ready. So you toggle it off and on, and it turns the enable off. So if I turn this off, I'm just going to say no. I'm not going to acknowledge the error. Let's acknowledge the error right here. So see how you have a fault right now, a fault status. So the AOI shows you right here there's a fault. And if I turn this bit on, I'm going to turn on the fault reset. So toggle this, and now the fault's gone. Simple. So I go to the FHPP monitor, message from PLC. So this is the enable. So the enable's off right now. If I come in here, turn this bit on, I'm going to turn the enable on, turn that on, and now the enable's on, and I have my status over here, ready to rock and roll. And this rung right here, the control safety, this is my own bit. You need this prior to any move. It's that straightforward. You know, you need a homing valve, you need the drive enabled, the load voltage applied. You need the drive to be ready, not moving. the HMI access locked, that basically is this right here, this bit right here. Or did I do something wrong? HMI access lock. Basically, it's the status of that bit somehow. Oh, it's an internal. You can set it the other way around. You have no faults and no warnings, and then you get a safety. So before you start any one move, you want that to be active. Unless you want a blend move. For example, and this code only starts point-to-point move. So basically, the access is at rest, and you're going to execute a move. You can, in theory, be in the middle of a move, like a direct mode move. Let's say you're going from position A to B, and you're in the middle of that move. It's executing. If you change the position target, cycle the start bit, it will execute the new move while interrupting the other move. Traditionally, you don't. What else here? Let me just see something. Start condition. So this right here, if you're doing record moves, the default start condition is ignore. Basically, what that means is that if you are executing move number 1 and it's actually moving and taking place, and then you change the number and then cycle the start, and you want to execute move number 3, it'll ignore that. You know, if you change this so that the interrupt is on and do the exact same thing, execute move number 1, and then now you want to execute move number 3 while move 1's executing, it will interrupt that move and start the new move. So that's something to understand as well. Homing, this bit right here, I've already homed, that's why the latch is on, but basically if you want at any time, you can execute that move again. I'm not going to do it right now, but the code works fine. And then we have the direct mode sequence. So we're in direct mode, and then we've got the sequence. It's just a little stepper here. Basically, you turn a bit on, you wait for the motion complete, then the moves are over here. So this is move 1, 2, etc. And in here, you know, it's your normal stuff. We're going to make it so that you're in auto. So I'm going to turn this bit on by toggling it on, and the stepper will control the events here. So each move has a speed percentage and a target. So you come into here, type in, you know, you want 20% of the max velocity, and you want to move to position 80.55 millimeters. That'll be that target. The next move, let's go 100% and go to 45. Next move, we're going to move really slow. 45, let's go to 35. And next move, we're at 35. Let's go 75. 60 and 1. Let's go 100% to target 1. And then the last move, looks good enough. So you've toggled this bit on, you know, toggle using the Control T, I use that. And then in here, I'm just going to Control T, which resets the stepper. This bit right here resets anything if you're in the middle of it, somehow it craps out, whatever. And basically, this right here is the enable. So turn this bit on, and it should be executing the code. And it's not. Let me look at something real quick. Okay, what I found wrong is that I had left the jog positive bit on, which you get an acknowledge for. Didn't even realize that. So basically, turn that off. I jogged it all the way to the software limits, so I'm just going to go back and turn this bit back on here. Fault reset, reset the fault, and go to the sequence mode. We're still in auto. All right, let's try this again. and we don't have the safety. Where's the safety? It's not ready. It's not enabled right now. Because I probably did something else wrong. Let's just turn this off. It is on. So now it's executing the moves. You'll see here 35. So it's basically stepping through, and then it basically sequence starts over, resets the stepper, and starts over. And you get the complete. So basically you get this bit precondition gets turned on, sends the command, and you get a complete. And then you move on to the next one. This rung here, that's up to you whether you want to use it. You can close the window on the actual position because the motion complete is probably a theoretical. It's really up to you. And I'm just going to turn this off. It should finish the sequence and then stop. You can see the motion complete going off and on. Target's changing. And it's finished its last move, and the stepper's been reset by the stepper itself. So now I'm going to go into record select. So toggle this, go to record sequence, toggle this real quick to make sure there's nothing left on. And then if we look at this record mode moves, same concept except I'm shoving a 1 or a 2 or 3. Basically it's going to execute 1, 2, 3, 4, 5, 6 all the way up to here. And then it's going to look again at the acknowledge start, the active, the acknowledge where it turns off, for the motion complete, and so on and so forth. So turn this bit on. You can see it again. It shows you right here by this number right here what record's being executed, and it shows you here as well when you're monitoring. So it's doing 6, and then it'll start over. It's just going to execute, continue to do that. So if you follow this structure here, you'll see that you'll have some success in programming. This sequence recovery, that's designed so that if you're in the middle of a move and you drop out a gate or an e-stop contact, it should pick up where it left off. No promises that it works, but I know that it's 99.9% functional and working. This is all sample code, so this is all for understanding purposes. If you use this code and it does not work, then you're on your own. It's got nothing to do with me. This is just me showing you a couple things. Common control, there's your start task based on a variety of different moves. Your desired target. I'm just translating the real number into a whole number that gets shoved out to the controller. Same thing with the actual, it's scaled. And I make sure that you never exceed your 0 through 100% velocity selection. And that's all there is to know about this particular CMMO-ST controller over iPort. I hope this helps you. This is Stephen Proud signing off on another video. Thanks.